Okay, so in this chapter, we're going to talk about what we call trigonometric identities. And trigonometric identities are basically equations which involve equal quantities, right? And they are equated to each other. So let's take a look at this first bunch here. There is nothing new in that first bunch of problems over here, right? Or in the first bunch of identities over here. All of these are relationships that you already know about, but now we're just going to give them a name, right? So for example, you all know that sine is the reciprocal of cosecant, right? 1 over cosecant is sine, and cosecant is 1 over sine. You all know this. You know that, cosine and secant are reciprocals. You know that tangent and cotangent are reciprocals. That's why these are called the reciprocal identities. You also know about some quotient relationships. You all know, for example, that tangent is sine over cosine, and cotangent is cosine over sine. Okay? All right. So what we're going to do now is we're basically just going to use the identities in order to find the quantities that we're missing. And I know, like, in the first few things that we're going to do, these are like such simple basic examples that you can just do them without thinking. But in pre-calculus, you're going to hear me saying this a lot. The process is more important than the final answer. So it's not the final answer, for those of you who are working ahead. It's not the final answer that I'm concerned about. It's the process. Okay? All right. So if cosine of theta is equal to 3 over 4. So basically for all of these, here's what you have to do. You have a given, okay? And you have to figure out what you want. In all of these, you have to identify what you're given and what you want. And then what you have to do, decide how you can relate what you want to what you're given. So for example, secant of theta is equal to 1 over cosine of theta, right? That's the relationship, that one is the reciprocal of the other. That means secant of theta, and also I want you guys all to get used to this. When you have 1 over something in your mind, that should say reciprocal. So I don't necessarily want you to write 1 over 3 over 4. I just want you to know that when you have 1 over cosine, that just means reciprocal, and you can just write this as 4 over 3. Okay. Here, you have secant of x is 5 over 4, tangent is 3 over 4, find sine. So these two are the given, and you want this. Okay, so how can I relate sine to something that I have? Well, I know that tangent of x is equal to sine of x over cosine of x. Yes? Okay, I have sine, but I don't have cosine. Oh, but I can find cosine, because cosine is 1 over secant x. So cosine is 4 over 5. That means, let's plug that in here. 3/4 is equal to sine of x over cosine of x, which is 4 over 5. And now how can I find sine of x? What do I multiply by? Multiply both sides by what? Not 5 over 4. By 4 over 5. So you see how this is sine of x divided by something? You multiply both sides by the something. So I multiply both sides by 4 over 5. Multiply by 4 over 5. Multiply by 4 over 5. Okay? Because now 4 over 5 altogether cancels with this. So sine of x is 3 over 5. Now, could you somehow manipulate that and do all that in your head? Possibly, because like I said, we're all intelligent human beings in here, and we can all do this, fine. But again, the final answer is secondary. The process, right, and showing work, that is what you need next year. Okay, that's what we're going to train you guys to do. Okay, now, everybody look here for a minute. Let's talk about, a random angle on the unit circle. We kind of did this last chapter. We're coming back to it. So when you have an angle anywhere here, right? Anywhere on the unit circle. Remember we talked last chapter about the vertical side. This is y, right? And this is x, right? And so if I wanted to write the Pythagorean theorem here, right? What is this? This is y squared plus x squared is equal to 1 squared, right? Okay, but we also said last time that y is always sine of theta and x is always cosine of theta. So instead of saying y squared, I could also write sine theta squared plus, instead of saying x squared, I could write cosine theta squared, right? That equals 1, right? If I just substitute. Yes, everybody with me? Now, another way of writing sine theta squared is sine squared theta. That's the most efficient way of writing it. That's how we normally write it. Sine squared theta plus cosine squared theta equals 1. Right? You guys all see where we came up with that? Okay. We used the Pythagorean theorem to come up with this, right? And now using the Pythagorean theorem, we came up with an equation that has, some trig value functions equated to something else. So this turns out to be one of the most important identities in math, and we call this the Pythagorean identity. Okay, just like the Pythagorean theorem, this is the Pythagorean identity. All right, sine squared theta plus cosine squared theta equals 1. And you're going to remember this and memorize it, and you're going to know it like you know your name. Okay, so we're definitely going to memorize this. Okay, now, here's what we're going to do. We're going to take that Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And just for fun, we're going to multiply through by cosine squared theta. Why? Because we can. Okay? Now, look at what I have here. I have sine squared over cosine squared. Now, sine over cosine is what? Sine divided by cosine is what? Tangent. Sine squared divided by cosine squared is tangent squared theta. Plus, cosine squared over cosine squared is 1 equals, what's 1 over cosine? Secant. And 1 over cosine squared is secant squared theta. And what does that get you? The second Pythagorean identity. Okay? You see where it comes from? So there's the 1, and then this is a derivation of it. Now, we're going to take our fabulous sine squared theta plus cosine squared theta equals 1, because it's our favorite Pythagorean identity. This time, guess what we're going to divide everything by? Sine squared theta. Okay, what do I get for the first term? 1 plus cosine over sine is what these days? Cotangent squared theta equals 1 over sine, which is cosecant, but it's squared. And that is the second Pythagorean identity, or the third, okay, the second one that we derived. So now, look at this. 3 siblings, okay? We're gonna have to use all of these, okay? They're all used equally whenever, the problem calls for one, we use the one that it's calling, right? I tell students, if you want to memorize all 3, fine. When you're stressed, it's gonna, you kind of forget where the ones are, the ones, the minuses, the pluses, whatever. There is no way to not memorize the first one. But know that you can always derive the other two, okay? If you get freaked out and you forget, you know how to derive them, okay? All right, so these are the 3 Pythagorean identities. Okay, so let's use them. Because what good are they if we can't use them? Okay. All right. Here we go. If cotangent theta equals 2, and cosine of theta is less than 0, find sine and cosine. You have seen similar problems like this in chapter 4. There was a test, there was one on the test, and we would draw triangles and find them, right? In this chapter, I'm not going to allow you to solve these using the triangles because this is the chapter where we're learning the identities. So I want you to solve them using the identities. Okay? Then on the final, you can do whatever you want. Okay? But in this chapter, we got to use the identities. So let's see what we're going to do. First of all, we have that cosine is negative. So that's in this quadrant and in this quadrant. We have that cotangent is positive 2. So that's in quadrant 2 and, positive 2. So it's in 1 and 3. Okay? That means my angle is in which quadrant? Third. Okay? The angle is in quadrant 3. Okay, so now, let's see what we are given and let's see what we need. We are given cotangent. We need sine and cosine. Okay? So, what you're going to do is you're going to go back and look at all the identities you now have in your database. Now we've got, this box and we've got this box. And you want to see how you can relate cotangent to one of the ones you need, right? So the easiest way perhaps is cotangent shows up in this third Pythagorean identity. But that connects it to cosecant, but that's okay because that's like sine, isn't it? Right? Yeah. So that's the one we're going to use. So how did we decide which one we're going to use? You've got to have an identity where the thing you're given shows up. In this case, it's this one. Okay, the thing I'm given. So let's write down the identity. So we're going to use cotangent squared theta plus 1 equals cosecant squared theta. Now, cotangent is 2. Cotangent squared is 2 squared. Plus 1 equals cosecant squared theta. Okay, so 5 is cosecant squared theta. Take a square root, take a square root. Cosecant of theta equals plus or minus root 5. That's important. Now, however, what quadrant are we in? Third. So it's got to be the negative. Okay, that's fabulous. We found cosecant. We didn't even need cosecant. What did we need?
But can it be positive though too?
No. No.
Oh, because for sine.
Yep. Sine, cosecant has to be negative in that quadrant. Okay?
Right.
Now, so we found cosecant, which means sine of theta is what? Negative 1 over root 5. So that's one of the things we found. Now, I need to find the other one. Now I need cosine. Is there an identity that relates one of the things we have to cosine? Sine squared plus cosine squared equals theta. Okay? Is there another one? Okay. There's one of these. We can definitely use one of these. Is there another one that relates? Okay, so what do we have? We have sine, cotangent. We need cosine. Is there another one here that we can use? How about this one? Cotangent is cosine over sine. We've got that one too, right? Does it matter which one you use? No. Which one would we choose? the easier one. This doesn't have anything squared. Let's use that one, okay? So, cotangent theta is equal to, what is it? Cosine theta over sine theta. So let's see what we have. Cotangent theta is 2 equals cosine theta over sine theta. What am I going to multiply both sides with? Negative 1 over root 5, the whole denominator. You would, but this is like cosine divided by this. You would do that if it was cosine divided by root 5.
Then you do 1 over root 5.
Right, but now you're going to do 1 over root 5.
So when you put the 2, just multiply by root 5.
So negative.
No. Because really what you have here, okay, so look, if you had like 2 equals cosine theta over x, over 3, what would you multiply by?
Multiply by 1/3.
You would multiply by 3.
Okay.
Right? If you were solving for cosine theta here, what would you multiply by? Here, you would multiply by 3 and 3, right?
Oh.
Yeah? You multiply by exactly, it's only confusing you because you've got a fraction in the denominator. I'll do some more practice with that later on, yeah.
But you said if it's like a square root, then, but like, I thought like when it's in the square root, you multiply by the numerator and the denominator.
You don't have to do that in pre-calc, remember?
Oh,
Okay, what we're doing here right now is you have to solve for cosine.
Yeah.
Now you have cosine divided by some number. So you have to multiply by the denominator in order to solve for cosine.
Right, but when you said when it's in a square root, then you have to do like the 1 over.
No.
Yeah.
No.
Okay, so it's still the same. Okay.
It's still the same,
Okay.
yeah.
How do we know it's negative?
Huh?
How do we know it's negative? Like the negative
Quadrant
5?
Because you know how like when we did the unit circle here, we decided that it was in quadrant 3?
Yeah.
In quadrant 3, cosecant or sine is negative.
Oh, yeah.
All students take calculus, yeah. So now cosine theta is equal to negative 2 over root 5. Okay, yeah.
Do we up top? Do we consider cosine is less than 0? Is that considered part of the given, or is that?
It was part of the. It was only used for the unit circle to see where you put the pluses and the minuses. Okay. Negative 2 over root 5. Okay. All right. Let's talk about cofunctions. Huh? Yeah, well, I'm going to go over that a little bit, yeah. So, cotangent is positive 2, which means it's in the first or the third. Cosine is negative, it's here, and then this is the quadrant where both of them match. Okay. All right, let's go to the next part, cofunctions. A trig identity, a trig function is a cofunction of another function if f of a equals g of b. Okay, so let me talk about this. Okay, let's talk about cofunction identities for a minute. Okay, what is sine of 30 from last year? I mean, from last chapter. 1/2. Okay, what is cosine of 60? You're onto something, Lauren. You don't even know. What's cosine of 60? 1/2. Okay? Okay, what do 30 and 60 add up to? 90. Okay. When you've got two angles, A and B, that are complementary, okay? And if sine of one and cosine of the other equal to each other, that means they are cofunction of each other. Now, this whole time we've been saying sine is the reciprocal of cosecant, cosine is the reciprocal of secant, but nobody ever asks, why is it sine and cosine, right? Why is it secant and cosecant? What do those have in connection to each other? Well, this is it. Sine and cosine of complementary angles are equal to each other. So for example, oh my God is right. I know you were. So for example, if you have sine of 40, that's the same as cosine of
60. No, 50.
50. If you have, I don't know, if you have secant of 20, that's the same as cosecant of 70.
Wait, why does this make sense?
I mean, do I look like I'm kidding? Okay. Why would I lie to you? Could you imagine if everything I've told you until now was a lie? It would be really funny, wouldn't it? And then you go to the SAT or something and it's like, right. Okay. So this does make sense. Of course it makes sense. It's math. So if you've got sine of theta, and this is why I assigned all those complementary questions in the last chapter. You see that? Because I needed to get you guys used to thinking about, because it would have been too late right now to remind you about complementary angles, okay? So, if you have sine of theta, that would be the cosine of the complement. So how would you find the complement of an angle? You do what minus what?
90 minus
90 minus theta, or in radian,
minus
pi over 2 minus theta. Do you see why I was asking you guys to find, like here is, pi over 4, find the complement, and you had to do pi over 2 minus. Do you see why those problems were assigned? Okay? It's all going to come together. All right? So, yeah. That's what happens. The second time it always makes sense. Huh?
This is the first time this year.
Okay, we'll get there. Yeah. This is the first time this year that things are making sense. Yeah. Yeah. Good. Good. Okay. So look at this. Good. Look. So these are the cofunction identities. Sine of theta is equal to cosine of the complement. Tangent of theta is equal to cotangent of the complement, and so on and so forth. Now, next, odd and even identities. These are also things that I started getting you guys used to before. Listen, Z. So look, if you have sine of negative theta, do you remember how last chapter we were saying that's negative sine of regular theta, right? Remember? If you have an angle theta, this is the sine, but if you've got negative theta, this is the sine, and you see how one, like plus and minus difference, right? One is positive, one is negative. That's this identity. Sine of negative theta, the y value in the negative theta, is negative of the y value of the positive angle. Okay? We did this last chapter. I keep saying last year. Now, cosine. Okay, so if you've got theta and negative theta, where is the cosine? The cosine is here, right? For both of them, that's the red cosine, yes? So cosine of negative theta is the same as cosine theta. You guys did this as a homework problem last chapter. This is why those were assigned, so that now we can get them back as actual identities. And so the only thing I didn't ask you to do is the tangent. Just remember, tangent of negative theta is like sine. The negative comes out. Okay, these are called the odd and even identities. I don't need you to memorize these, but understand them. That's why I assigned the problems last time. Okay, so if Sine of x is 4/5. What's sine of negative x? Negative 4/5. So if you have sine of a negative angle, the negative comes out. Okay. Now, hang on. What's cosine of pi over 2 minus x? So cosine of the complement. Here, cosine of pi over 2 minus x is just sine of x 4/5. Okay, what is this? This is the complement of x. And remember what we said. Cosine of sine of x is equal to the cosine of the complement. So the cosine of the complement is equal to the sine of x. I'll write it this way. So cosine of the complement is equal to sine of x. Okay? That's this identity here. Okay, all right, very quickly, because we got to move on.
So with complements, if you have like a negative angle,
Okay, we're going to do that right now. Wait, hey, maybe hang on. Okay.
So if that problem A right there, if it is then find cosine of negative x, would it just be 4?
Okay, hang on. Wait, because the next problem is going to explore a little bit of that, okay? Okay, cosine of x, now we have cosine of x is negative 0.75. I want to find sine of the complement. So if you have cosine, sine of the complement is the same, right? Exactly, it's the same. So sine of the complement is equal to cosine of x, which is equal to negative 0.75. You can leave it. It's up to you. If it's given in a fraction, leave it as a fraction. Or if it's a decimal, leave it. It really doesn't matter. Now, here. Oh, you know what? Actually, wait a minute. I meant to make this a sign. Make this a sign. Okay, so here I was asked to find sine of the complement. Okay, sine of the complement is equal to cosine. Now, so this is sine of pi over 2 minus x. This is sine of x minus pi over 2. How are those two related? How is this related to this? They're not inverses, they're negatives of each other. Do you see that?
Oh yeah, it would just be the negative.
Right? Because if this is like negative x plus pi over 2 would give you that. So this is the negative of that. So now, if I want sine of the negative thing, what would happen to that?
It would be negative cosine. It would be negative cosine.
This is negative sine of the other one.
Where's the negative though?
Negative cosine.
Okay, if you have pi over 2 minus x,
Yeah.
this is the negative of x minus pi over 2. Okay? Because distribute the negative, what happens here? Negative x plus pi over 2. Right, so one is the negative of the other. Yeah.
Why wouldn't it be negative cosine?
Now it's going to be negative cosine. Okay, so first, so sine of this is negative sine of that, which is equal to negative cosine of x. Okay? So now this is negative. How much is cosine of x? Negative 0.75. So all this together would be 0.75. Okay. Let's do the other stuff. Now, with the other page, okay, it says to simplify in the other page. And, you know, the thing about simplifying is students often don't know how much to simplify, and for good reason. So I'm going to try and make it, so I'm trying to, you know, debate for like, I might give you like what your answer should look like so you have an end goal. Because sometimes like students get confused like how simplified is simplified sort of a thing, okay? So to simplify, first of all, start by rewriting it in terms of one. Okay, so let's simplify some of these. So here I have 1 over cosine x times 1 minus sine squared x. This I can't really do much with. Now, I have another term here, 1 minus sine squared x. That is a special format, right? And the way, and as soon as I see that, I can recognize exactly what that is. And what triggers me is this, that there is a trig function squared added to or subtracted from a 1. So whenever I have sine squared, cosine squared, cosecant squared, and then I have a plus or minus 1, the first thing I'm going to think about is Pythagorean identities. So the Pythagorean identity that has a 1 and a sine squared is the first one. So I write that one here, sine squared theta, or sine squared x, plus cosine squared x is equal to 1. But I need to rearrange that so I have 1 minus sine squared x. In order to get 1 minus sine squared x, I can subtract sine squared x from both sides. So now this will turn into cosine squared x is equal to 1 minus sine squared x. So do you see how this term here, the 1 minus sine squared x, is the same as this, and that equals cosine squared x. So I can substitute cosine squared x for that one term. Now I have 2 cosines on top, 1 on the bottom. Cancel them out, and I just have cosine of x left. Okay, next. What I have next is cosine x tangent x minus sine cosine squared x. So what I'm going to do is, first I'm going to write everything in terms of sine and cosine. Okay, so the first one, cosine x times, okay, the tangent x is actually sine x over cosine x minus sine x cosine squared x. Okay, now you notice there is a cosine square, there is a cosine on top and on the bottom that can cancel out. So that means what I have now is sine of x minus sine of x cosine squared x. Okay, what could I do now? Well, I have a sine and a sine here, right? So I have sine of x in both of these terms. What I can do is I can factor out a sine. Okay, so I factor out a sine x, and when I factor out a sine x from here, I get 1, minus when I factor out a sine from here, I get cosine squared x. Now again, I have a similar term here. I have sine of x times, I've got a term here that's a trig function squared plus or minus a 1. Well, that's cosine squared. It's going to be the same identity. Sine squared x plus cosine squared x is equal to 1. This is the identity that has cosine squared in there. So how do I make this look like 1 minus cosine squared x? Okay, so I'm going to subtract a cosine squared x, subtract a cosine squared x, and I get sine squared x equals 1 minus cosine squared x. So basically this is like a puzzle. I'm looking for something to substitute for the 1 minus cosine squared x, right? And that happens to be the sine squared x. So altogether, this is sine cubed x. Now, this next one, right? I'm trying to do one of each type of problem. This next one, when you have a fraction, let's forego, like let's put on hold putting it in terms of sine or cosine. First, I like to put it in terms of one fraction. So I want to do a common denominator. To do a common denominator, this is going to be 1 minus secant x, 1 plus secant x. Okay? All right. So when you multiply the first fraction by the denominator, By the common denominator, you have secant x, 1 plus secant x, minus, multiply again, you have secant x, 1 minus secant x, equals. Okay, we're going to distribute the secant x now. So I'm going to get secant x plus secant squared x minus, now I'm going to distribute negative secant x. So minus secant x plus secant squared x all over this. Okay, look at what I have here. A minus b, a plus b, right? So it's going to be 1 minus secant squared x. Square the first, square the second, and a minus in the middle. Okay, now something beautiful happens because I've got a positive secant x and a negative secant x, and those cancel out. I've got positive secant squared. I've got a positive secant squared and a positive secant squared, and that will be 2 secant squared x over. Okay, now I've got this thing again. I have a 1, a plus or minus, and a trig function squared. But this time it's secant squared. So what's the identity that's got secant squared in there? Well, it's that second one. Tangent squared plus 1 equals secant squared x. So let's write that here. Tangent squared x plus 1 equals secant squared x. Okay, now what am I going to do to this to get 1 minus secant squared x? So to do 1 minus secant squared x, I need to bring secant squared x to that side. So I'm going to get 1 minus secant squared x, but then the tangent square has to go to the other side and it becomes negative tangent squared x. So 1 minus secant squared x is negative tangent squared x. So here this is negative tangent squared x. Now let's see what we've got. Now we can put it in terms of sines and cosines. So this is 2 secant squared x, which is 2 times 1 over cosine squared x, minus over negative sine squared x over cosine squared x, equals 2 over cosine squared x times the reciprocal of the denominator. Okay, there's a minus here. Cosine squareds cancel. So I have negative 2 over sine squared x.